Hi, I'm Sarah Murnen, a professor of psychology at Kenyon College. I'm going to talk about conducting t-tests using SPSS. First, I'd like to go through the example that I'll be using. Okay, in this example of t-test, I'm going to talk a little bit about a data set we've collected concerning multiple roles and well-being. So basically, fulfilling multiple roles in life has been associated with greater well-being. However, wanting to achieve perfection in these roles is hypothesized to be unhealthy. And it's recently been suggested that there are increasing demands on women, particularly to achieve perfection in multiple roles, which is stressful, putting women at increased risk for depression and eating disorders. Some of these ideas come from the idea about the superwoman ideal or the triple bind. It's also been hypothesized that there are increased pressures on men too, specifically about maintaining a perfect body. The thin ideal for women, the muscular ideal for men. In the present study, we wanted to test some of these ideas, developing scale items to measure desire to achieve perfection in multiple roles. And we wanted items that both women and men can respond to, which on some scales that's not possible. Briefly, we're sampling 3 different domains concerning roles. Traditionally masculine roles, such as being an authoritative expert, traditionally feminine roles, such as finding the perfect match in a romantic partner, but we're also looking at the appearance domain, since that's believed to be putting increased pressure on both women and men. Commanding a lean, toned physique is an example of an item in that domain. So I'm only looking at a very small portion of the data here for this example, but I just wanted to give you some background on where these items came from. The participants in the study were unmarried individuals ages 18 to 30 who were recruited from a service that Amazon has called Amazon Turk. So they filled this out online. It was created by SurveyMonkey, and they were paid a small amount of money to do this. Now, people are asked to indicate their interest in achieving in many different domains. So they're given a whole list of items in those 3 general domains I talked about. And they're asked to indicate for each item how important it is to achieve in that domain, either now or in the future, where 1 equals not at all important and 5 is extremely important. So that typical Likert scale that we see in psychology. So then we're going to look at some of these data and use some t-tests to analyze them. Now generally, t-tests are used to compare 2 means to one another, and you would conduct an independent groups t-test if the means that are being compared are from 2 different groups of people, 2 independent groups, or you might talk about it as a between subjects design. A correlated groups t-test, or sometimes called a paired samples t-test, is used if the means are from 1 group of individuals or a group that is matched in some way. Now the basic meaning of the T formula, you can go back to your statistics book to look it up, how to calculate it exactly, but what you're looking at is the observed difference between the means in the numerator of the formula. So the mean from 1 group or the mean of a group of individuals of the pretest compared to the mean of a second group if it's an independent groups t-test, or a post-test score, for example, if it's a paired samples t-test. So you're looking at a difference between the means in the numerator, and then generally what's in the denominator is assuming that the null hypothesis is true, that there is no difference between the means. You can still get a difference based on sampling error alone. So that's what's in the denominator, the difference based on sampling error alone. So if you come up with a t ratio that's very large in absolute value, it means that there is a fairly large difference between the means, bigger than what you'd expect based on sampling error, so you reject the null hypothesis. Note that t values can be negative or positive based on the fact that you are taking a difference between 2 means. So I'm going to start with the independent groups t-test. And in this example, my independent variable, it's a between subjects variable, has 2 levels, is gender. So I'm going to compare women to men. Now I'm actually going to do 3 different independent groups t-tests. Remember, I have an item from each of those domains. So I'm going to compare women and men's responses to the masculine item, which is scored 1 to 5, the feminine item scored the same way, and the appearance item. So now I will switch to my SPSS file and show you the independent groups t-test. Okay, so here we are now in our SPSS data file, and let me just show you a little bit of what's in here. So obviously I've only taken a very small portion of the data here, and this is the score on the feminine item about romance. This is the masculine item about wanting to be an authoritative expert, and this is the item about leanness, which is in the appearance domain. So gender is coded 1 or 2. I'll look at that. I also have age in here. I have subject number. But let's take a look at the variable view to figure out what the gender labels mean. I do like to put value labels in here. And I've coded this such that 1 equals female and 2 equals male, so that I can remember that. Okay, now to conduct an independent groups t-test, I go up to Analyze, Compare Means, and I see here that I have independent samples t-test. So I'm actually going to do 3 different t-tests. I'm going to look at gender differences on the romance item, how much they value wanting to find the perfect romantic partner, how much they want to be an authoritative expert, that's the knowledge one, and how much they want to command a lean toned physique, that's the lean item. So those are my dependent variables, and then gender is the grouping variable or the independent variable. Sometimes the labels that SPSS uses are not the ones we talk about in class, but now it wants to know, well, which specific 2 groups are being compared here. Under defined groups, I need to put in the labels that or the numbers for the groups I want to compare. 1 for women, 2 for men. Notice here there's something called a cut point. Sometimes you want to take a continuous variable and divide a group in 2 based on, for example, the median. And you could put the median score in there and it would divide the group in 2 on that variable. And then you would compare those 2 groups on some other dependent variable, some dependent variable. But here I'm doing gender differences. Now, really, I don't have to do much in terms of options because it will give me the means. It'll give me all the output that I want here. Okay, so the first thing to look at here is just taking a look at the means. So on the romance item, we have 221 women, and the mean score, remember that's a 5-point scale, is 3.83 with a standard deviation of 1.09. And the mean for males, there are 381 males, is 3.66. Now those look like they're different from one another, but that difference might be attributed to sampling error. We do not know yet if it's statistically significant until we look at the t-value. For the knowledge item, the difference looks a little larger, but again, we have to take sampling error into account. And the lean item, those means look fairly similar. I doubt that one's going to be significant. So down here is the result of the t-test. The first thing here is the way that we calculate the t normally is we're going to assume that the variability in the 2 groups is equal. That's the homogeneity of variance assumption. Now there is an actual test for this, Levine's test for equality of variance. If you have violated this F will be statistically significant. We'll have a probability less than 0.05. And if that is the case, then you should go ahead and use the t where equal variances are not assumed. And what happens there is it's a different way to calculate the t. It's based on fewer degrees of freedom, fewer numbers of independent pieces of information. And you want to have more degrees of freedom if possible. It gives you a more powerful test. But you can't use it if you have violated the assumption of homogeneity of variance. We have not, however, not for any of these tests. So here's the comparison for romance. The t-value, remember that this ratio is going to be quite large if the difference between our means is larger than the difference we expect based on sampling error. Well, here it's 1.8 times larger, and it turns out that that is not statistically significant. We are looking for a probability less than 0.05 for that. So this T with 600 degrees of freedom, remember the degrees of freedom is N1 plus N2 minus 2. And that's based on the number of people who answered the question. So you can see that it's a little different for these three tests. But anyway, it is not statistically significant. The difference between those means could be attributed to sampling error. It's close, but not significant. However, on the knowledge item, again, we have not violated homogeneity of variance. That T with 598 degrees of freedom is statistically significant. It has a probability less than 0.05. It doesn't account for a lot of variability. Remember, to get the eta squared, you can take that T value, square it, and then divide by T squared plus degrees of freedom to see how much of the variability in those knowledge scores is associated with gender. It's not going to be a lot. But in any case, it is statistically significant. To interpret the nature of it, you go back and look at, well, whose mean is larger? Men agree with that item more than women do. And the T is negative because we put the mean for the females in the formula first and then the mean for males. And that's a difference between the means that's in the numerator, resulting in a negative formula, negative T value. Leanness item, again, we have not violated homogeneity of variance assumption. That T doesn't even exceed a value, absolute value of 1. That difference definitely, there's no significant difference. Those are very similar to one another. So that is interesting, and that's telling us that the only significant difference was on that knowledge item. And actually, across all the items that we looked at, there's a lot more similarity than difference, suggesting that pressures associated with these roles are pretty similar for both women and men. Now what I want to do is talk about a correlated groups t-test. So I'm going to go back to my PowerPoint and talk about how we can do that in this same data set. Okay, for a correlated groups t-test using the same data set or a paired samples t-test, your independent variable here needs to be within subjects. Again, the dependent variable is quantitative, measured on an interval level scale at least. And typically this is used when you have one group of people, you're looking at a pre-test score compared to a post-test score. But in our example, what we could do is look at women separately and see whether they agree with one of those scale items more than another. So compare their responses, for example, to commanding a lean physique. Is that more important than a romantic relationship, which is a traditionally feminine thing to care about? I can do something similar for men, but compare the leanness item to how important the being authoritative expert is. So let me take a look at that in SPSS. Okay, now I'm back in SPSS, and what I need to do in order to conduct this paired samples t-test is first I'm going to select the data for women. So we go up to data and we do select cases and we set up an if statement. So if gender equals 1 is going to give us just the women in our sample. So I say continue and then I say okay. And to know that it did this, if we take a look at the data, it will have crossed off, it should have crossed off the data for people who aren't women. Can't tell that it did this, but in any case, now that I've selected only the women, I want to go to Analyze, Compare Means, and look for the Paired Samples t-test. And then what I do is put in the pairs that I want to compare. I want to see how they responded to the romance item versus the leanness item. Did they care about one more than the other? And was it a statistically significant difference? Now with the correlated groups t-test, that denominator of the formula that reflects sampling error is often quite small. Because we are using the same individuals, we're taking out a lot of variability due to individual differences. So even a fairly small difference between the means and the numerator might be statistically significant. Okay, I need to go to the output to see what happened. And here's the paired, it did not select the data for just the women because look, it has 600 people there. So let me go back to that. Data, select cases, if That's why I couldn't see it. If gender equals 1. Continue. Okay. Now, if I go to the data, it crosses it out. If their gender is equal to 2, it's not including them in the analysis. Okay, I should have trusted that. But let's go back to the analyze, compare means, paired samples t-test. Okay, it's in there. I also don't have to select options for this because it'll give me what I want. All right, here we go. This is the sample size for women. Here's how they responded to the romance item. Fairly strong agreement on a 5-point scale, close to 4. Whereas for the leanness one, not so much. Is it a statistically significant difference? If I go down here, it's kind of hard. There's a whole bunch of information here, but here's the t-value, the degrees of freedom, and the statistical significance. And it is very statistically significant. Again, this can be a very powerful test. So what we say is a t with 220 degrees of freedom equals 9.28, probability less than 0.001. Remember, there's no such thing as a probability of 0, but because it only carries it out to 3 decimal points, we would want to say probability less than 0.001. So women, agreed more with the romance item than the leanness one. So even though there are concerns about appearance, maybe other concerns are more important to women here. So now let me look at the men. I go back to data, select cases. If gender equals 2, will give me the men. Continue. Okay. Notice it changed. Well, you can't really see that, I don't think. But it did change to select the men. And I'm going to go back to analyze, compare means, and paired samples t-test. I'm just going to reset it. Otherwise, it's going to give me the same one I asked for. And what I want to do is compare the knowledge one to the leanness one for men. Okay, so I have 376 men. Here's how they responded to the knowledge one. And here's how they responded to the leanness one. There's actually, in this case, a little more agreement about the leanness thing than being an authoritative expert. Now, we're not, in our final data, we're not relying on just one item in that masculine domain to tell us about that. So this is just one item on there, but there's, there are more. But in any case, this T, not as large as the other one, but it has 375 degrees of freedom. It's 5.29. Again, it does have a low probability less than 0.001. So men agree more with the leanness item. They care more about that than being an authoritative expert. So that's the correlated groups t-test. And thank you for your attention.